Welcome to this video on data flow and reuse. We will explore the mechanics behind caching, buffering, and database buffer pools. Computer architecture involves a fundamental compromise. Faster data access often means smaller, more expensive storage layers. Systems must constantly decide what to keep in fast memory. Caching is about remembering data. It prevents redundant work. For example, reading frequently accessed data from RAM instead of slower storage. The goal of any cache is a high hit ratio. Achieving a high hit ratio is crucial for performance, especially when accessing underlying storage is costly. Buffers serve a different purpose. They hold data temporarily while it is in transit. This absorbs rate differences between producers and consumers. Buffers smooth out mismatches. For instance, a print spooler holds documents so that a fast application doesn't have to wait for a slow printer. In summary, while caches are for avoiding repeated work and expecting reuse, buffers are for managing flow between mismatched systems. A database buffer pool synthesizes these concepts. It acts as both a cache for read operations and a write buffer for data destined for storage. Because RAM is limited, we face an eviction problem. Database systems use algorithms, like least recently used, to decide which pages to remove when the buffer is full. The buffer pool also manages dirty pages, data modified in RAM, but not yet written to disk. It actively coordinates these writebacks to persistent storage. The buffer pool is a single source of truth. Databases use internal locks and transaction mechanisms to ensure data integrity, preventing external corruption. Caching is a fractal pattern. From browser requests down to the CPU, these same principles of fast access and eviction apply throughout the cloud stack. Remember, caches provide reuse, while buffers provide flow. The database buffer pool is the architectural synthesis of both concepts.